Hey guys, it's Mr. Chu, and in this video we're actually going to come up with the formula to find the sum of a finite arithmetic series. And so it actually comes from the story about a young mathematician whose name is Carl Friedrich Gauss. And so the story goes that when he was in elementary school, his teacher gave his class what they thought would be a challenging problem, which was to find the sum of the first 100 integers from 1 to 100. And so he actually did this in his head. In order for us to kind of talk about it, let's actually look at the sequence itself. So 1, 2, 3, all the way to 100. So again, we're looking at 1, 2, 3, and then going to 100. Now, this is actually an arithmetic sequence because it goes up by 1, so your common difference is 1. And we're looking at a finite sequence here. Okay, so it stops at 100. The way that Gauss actually looked at finding the sum so quickly was he noticed that there was a pattern. He saw that looking at the first and the last term, it added up to 101. Looking at the second and second to last term, they added up to 101. Looking at the third and third to last, added up to 101. And he kept doing this all the way till he got to the middle. So he got to 50 and 51. Now, what he actually found was that these were partial sums. Now, a partial sum essentially is just pairs. Okay, so he looked for pairs of numbers that added up to the same thing, in this case, which was 101. Now, from the numbers 1 to 100, we have 50 partial sums. Okay, and if we really wanted to list them out, you can take out a scratch sheet of paper. It'll take you a few minutes, but you can pair up 1 and 100, 299, 398, 497, 596, and so forth until you get to 5051. Now from there, what Gauss did was he actually looked at the total number of pairs, or total number of partial sums, and he multiplied it by the total that each of those pairs added up to, which was 101. And so very quickly he got this total of 5,050. Now here's the important part. There were how many total terms in that sequence? There were 100. How did we get 101? Well, we looked at the first term plus the last term. But if we're trying to get this to look like this up here, we need to somehow get a 50. And it comes from this idea of pairs. So we're looking at how many pairs of 101s are there. So that's where we get 100 over 2 times 1 plus 100. Now, generally speaking, what we can do is we can come up with a formula. And so that formula, we're going to go ahead and say is S sub n equals the total number of terms divided by 2, because that's talking about how many pairs we have, times the first term in the arithmetic sequence plus the last term in the arithmetic sequence. And that's it.